So the first question is this. Using the principle of mathematical induction, prove that sigma r plus r into r plus 1 is equal to n over 3, n by 2, n over 3, n plus 1 into n plus 2 for all positive integers So I hope you all got the question. Okay, let's start. You can all see the good theory, right? So when you have a mathematical induction question, what do you do first? Well, first of all, let's understand what's the question. We need to prove that sigma r into r plus 1 is equal to this. So what do you mean by this? If you don't understand, you can put in the chat and I'll stop and explain, okay? So first of all, let's just explain what this is into r plus 1. So this is basically the summation. So what do you do? R goes from 1 to n. So first it's 1 into 1 plus 1. Summation. So add the next term. What's the next term? 2 into 2 plus 1. And it goes on until what? N, which is n into n plus 1. So that's basically what this part means. So what we need to do in mathematical induction is basically 3 steps. First, we need to prove the case, the statement, they have given the statement, this is equal to this. We need to first prove the statement is true when n is equal to 1. That's the first step. The second step is we need to assume that the statement is true when n is equal to p. P is just an arbitrary number, it could be any number. And then what we need to do is we need to prove that the statement is true when n is equal to p plus 1. So simple, just 3 steps. First, you assume when n is equal to 1, so you prove when n is equal to 1, the statement is true. And then you assume when n is equal to p, the statement is true. And you then try to get the value when prove that when n is equal to p plus 1, the statement is true. So those are the simple steps we need to follow. So are you with me so far? Okay. So let's first do this first step. Step 1 is when n is equal to 1. So first you take the left hand side. LHS stands for left hand side. So when n is equal to 1, you go from 1 to 1. That means there's only one term. The first term is 1 into 1 plus 1. So the answer would be 1 plus 1 is 2. The answer is 2. So next what you do? You look at the right hand side. So what is the right hand side? When n is equal to 1, right hand side is 1 over 3 into 1 plus 1 into 1 plus 2. So if you simplify this, 1 plus 2 is 3. You can cancel these 2. The answer would once again be 2. 1 plus 1 is 2. So we can say the left hand side is equal to the right hand side. So now what we know, when n equals 1, the statement is true. So that's the first part. Is that clear? So erase this part. So the next thing we need to do is when n equals to p plus 1, we assume that the statement is true. So suppose when n is equal to p, the statement is true. Now what do I mean by the statement? Statement is this thing, right? This is equal to this. That's what is true. Which means we go from sigma r plus 1, n equals 1 up to, r equals 1, not n this time, up to p. So would be equal to, when n equals p means you substitute p for this. So it's p by 3, p plus 1 into p plus 2. Okay. So this is we assume that now one common mistake that people will do it like they substitute P for here, R equals 1 to P this one. But you don't substitute P. What it means by P is it goes up to P. R equals 1 to P. R, we just substitute the values for R. So it should be P here. Don't put P here. So the P should be on this side. P over 3, P plus 1, P plus 2. Now, I'll erase this part for a bit. Right. So now what do we know? We know that n equals to P, the statement is true. What we need to prove, the third step is when n equals to P plus 1, the statement is true. How do you do that? Now, as I said before, the sigma, this statement means it goes from 1 into 1 plus 1 plus 2 into 2 plus 1, and it goes on, right? Now, what's the, if it goes up to P, it will be P into P plus 1. So basically this means this whole term. Now, what would be the next term in this system? If you were to add something and make it the next term, what do? You add 1 to each thing. So it's P, it becomes P plus 1. And where P, you again add P plus 1. P plus 1 plus 1. So it's P plus 1, P plus 2. I think it's not very clear. So anyway, this term is P plus 1, P plus 2, right? So if we can add this term, P plus 1, P plus 2 to this side, we can make this go from 1, not to P, but to P plus 1. Okay? If you don't understand, put it right. Okay. So what we know, what we need to do is to both of these sides, we add the same term, P plus 1, P plus 2. Add P plus 1, P plus 2 to both sides. Both sides of this equation, okay? So we get sigma R equals 1 to P, R plus 1 plus, now what do we have? P plus 1, P plus 2. So the next side also, we have the same thing. P over 3, P plus 1, P plus 2. We had this term, P plus 1. Now already you can see there's something common here, right? P plus 1, P plus 2, P plus 1, P plus 2. So now itself we can think, okay, this is the right, we are on the right track to get the answer. So what is this? As I said before, what is this whole term? For this, we added the next term, P plus 1, P plus 2, which means this is actually R equals 1. It goes not just to P, but to P plus 1. Up to P was this, and the next term was P plus 1 plus P into P plus 2. And we added that. Together, we can say this whole term can be written as R equals 1 up to P plus 1. Remember, the P plus 1 comes on top, not in this thing. Okay, so here what can I do? We can take the common factors out. We can say P plus 1, P plus 2, P plus 1, P plus 2. Can I take this out? Yes. So if we take the common factors out from this, what are the remaining terms? Here, P over 3. Plus this whole thing we took out. So the answer is 1. Only 1 remaining itself. So I can simplify this further. This can be written as P plus 1, P plus 2. So 3, you multiply 1 by 3. That means 3. So it will be P plus 3. Now divide the whole thing by 3. Now what do we need to prove in the end? We need to prove that this statement, the first statement, is true when n equals to P plus 1. So we got n equals to P plus 1. Okay, this side is okay. So we need to prove this part. Is this part coming from this? So how do we do that? Everywhere where n is, we substitute P plus 1. I think you can see it's in the same form. Just to make it more clear, I'll write it again. So we can say P plus 1. where n is there, I put p plus 1. And then p, once again, when n is there, I put p plus 1. So p plus 1, 2 can be written as p plus 1 plus 1, right? And then p plus 3 can be written as p plus 1 plus 1. Is this in the now? Is this in the same form as this? N by 3, p plus 1 by 3, n plus 1, p plus 1 plus 1, n plus 2. Sorry, this is p plus 1 plus 2, right? So now we can see that the statement is true when n is equal to 2, n is equal to p plus 1. The statement is true. So did you understand that part? Okay, the is. So what we can then do, now we need to write a statement, writing or combining all of this. So first we write, I don't have space here. I'll just write it here. So we need to write when n equals to p1, the statement is true. Then you assume or suppose when n equals to p, n equals to p, the statement is true. You can write the same thing. When n equals to p, the statement is true. When n equals to p plus 1, we prove that this statement is true. Now write the statement at the end. Therefore, by mathematical induction, write mi for simple. So it's mathematical induction. By mathematical induction, the statement is true for all n element or positive integers. Okay, so is that represents integers, positive represents the positive integers. So that's basically the first question. So if any got any questions, you can put in the chat or you can unmute yourself and ask as well. If you understood, you can just put it's clear. I understood. Oh yes. Right. It seems clear for everyone, right? So basically what we did, so if you have a mathematical induction problem, so there are basically 3 steps. N equals 1, the statement is true, you need to prove that. You just substitute 1 for the left-hand side, right-hand side, and try to see if this is equal, then that's done. So when you've done that, then what you do is you assume when n equals to p, the statement is true. And when you've done that, you try to prove from that when n equals to p plus 1, the statement is true. And if you can do that, these 3 steps, you can write this state n equals 1 is true, n equals p is true, n equals p plus 1 is true. Therefore, by mathematical induction, it's true for all real numbers, all positive numbers, n equals for all positive integers. Right. So I think everyone understood. So like before going to the next question, some people like have this question about mathematical induction. What is mathematical induction? What am I doing? Like I know what to do. Like this is what I do. N equals 1. Okay, n equals p. I assume it, and then n equals p plus 1. I prove it, and then I just write the statement. It's true. But what am I really doing? And like, and there's an assumption in the middle. How do I even know it's true? So have you guys like got those questions? I don't know. I had those questions sometimes. So I knew what to do, but like, why do we do this? So I had those sort of questions. So I'd like to sort of explain what mathematical induction is before going to the next question, if that's okay. Tell me. It is this. So like imagine you were like playing around with numbers and stuff, and you suddenly came up with a cool result. So you were like saying, okay, one can be written as, let's say, okay, 1 divided by 2 into, let's say, you add another one. So okay, 1 plus 1 is 2. You divide it by 2, it cancels off, it becomes 1. What if I had another number? Let's say 1 plus, let's say 2. Can I like write it in the like a same format? Let's see. Let's take the last number, that is 2, and let's divide it by the same number 2, and then let's add 1 to it. 2 plus 1. So is this correct? So 2 plus 1 is 3. 2 divided by 2, it cancels off. This side is also 3. So these two are equal. Is this true for 3 also? Let's just take 1 plus 2 plus 3. So once again, the last number, 3, divided by 2 and add 1. 3 plus 1. So is it true? 3 plus 1 is 4. 4 divided by 2 is 2. 2 times 3 is 6. 1 plus 2 is 3. 3 plus 3 is 6. So the left hand side is equal. So now you're like, oh my god, I have found a theorem. So what's this theorem? So let's say if it's num1 plus 2 plus up to let's call it n. So if it's n, you get the last number, n divided by n divided by 2 into, let's put this number, n plus 1. Okay, but is this theorem correct for all the numbers? I mean, it's true for 1, it's true for 2, it's true for 3, but is it true for all the numbers? So you spend your whole life like trying to prove that value. So you try for n equals 3, n equals 4, n equals 5, and like when you get like n equals 100,600 something, you're done. So 100 years later, somebody comes and says, I have proven that this theorem is wrong when n is equal to 1,776,788. And you're on your grave like, not now. But what if you had a method of proving a theorem for all the numbers without proving for all the numbers? And that's where mathematical induction comes into play. So look at this statement. If n equals to p, the statement is true implies n equals to p plus 1, the statement is true. So if you can prove this, now p is just a number, right? So let's say n equals to, let's say 4. If it's true for 4, let's assume that it's true for 4. This statement says if it's true for 4, that means it's true for 5. Okay, it's true for 5. Okay, the statement says that if it's true for 5, it's true for 6. That means it's true for 6, it's true for 7, and it's true for all the numbers. But wait, we assumed if n equals p, the statement is true. How do we even know if n equals p, the statement is true? Well, we first proved when n is equal to 1, the statement is true. It would be left hand side was 1, right hand side was also 1. We actually proved when n equals to 1, the statement is true. That's no assumption. It is true. Okay, n equals 1 statement is true. We also know this. That means if it's true for 1, it's true for 2. If it's true for 2, it's true for 3. If it's true for 3, it's true for 4. It's true for all the values up to infinity. So in just 3 steps, you prove the theorem for all the numbers without proving for all the numbers. And that is the power of mathematical induction. Did you understand actually what a little bit idea of what mathematical induction was? So like you get this question like we know what to do, but we don't really know what we are doing. So you get these ideas, questions in your mind, and like when you get the meaning, it's more fun, right? So shall we move on to the next question?
Can we do this question using a series knowledge also?
Okay, I couldn't get your question.
Yeah, I mean, can we use the series knowledge also for this question?
Yeah. So this is actually a theorem that you might have learned this from the series thing, 1 plus 2 plus up to n is n equals 2. But if you want to prove it, you can prove that this theorem, this one using mathematical induction. You can try it at home. Just do it n equals 1, this, n equals p, that plus 1. Like that's a theorem, right? In a series, 1 plus 2 until n is equal to n over 2 n plus 1. You learn this in, I think, O levels or something. So you can prove this theorem using mathematical induction. So mathematical induction is basically used to prove stuff. Get it?
Yeah, understood.
Okay, so for this third step, how did we find out we should add p plus 1 and p plus 2 into p plus 2 to both sides? So this is from the question we did before. So what we are trying to do is, we know is the statement is true when n equals to, we assume n equals to p plus p is true. Now what we need to do is, we need to get from here, we need to go to p plus 1 case. Now what is p plus 1 case? So as I wrote before, the meaning of this is 1 into 1 plus 1 plus 2 into 2 plus 1, and it goes into p into, until the last one, p into p plus 1. So one person has asked a question, how do you know what to add next? Now, if you think of this, what is the next term? Like if you're going to go, like what happens every time you add by 1, like 1, 2, it goes 3. So, and this also 1, 2, it goes to the next one. So what is the next term that can be added? So this is p plus 1. So what you do is add 1 to both sides. So p, what's the next term? If you add something next term, this becomes p plus 1. This becomes p plus 2, right? Now, if we, now what is this? This is not just up, this is up to p, okay? This is up to p. Now, if we add this term, it will become up to p plus 1. So what we are trying to do is, we are trying to go from the p case, the case where r is 1 to p, we go to the p plus 1 case. So for that only, we first of all, you have to think, what is the number that you need to add, so that we can go from this to this. So once you got that, then you can add that to both sides. So I hope that answers the question. All right, anything else? Okay, shall we go to the next question? I'll raise this. Okay, this is the next question. Sketch the graphs of y equals mod x plus 1 and y equals mod x twice mod x minus 1 in the same diagram. Hence or otherwise, prove for all values, all the real values of x satisfying the inequality this. So what we basically have to do is, you sketch the graph of the first graph, the second graph, sketch it in the same diagram, and then we sort of try to prove this inequality. Mod x plus 1 is greater than the range where of f of x, where mod x plus 1 is greater than twice mod x minus 1. So I think hope you all got the question. Shall we start? Okay, first thing says, like they say, sketch it in the same diagram. So first sketch it separately, and then you can put it together in one diagram. So the first thing is y equals mod x plus 1. So what is mod? This is modulus. So modulus means it's always positive. So if it's even, if it's 1, it will be 1. If it's minus 1, you take the modulus value, it will still be plus 1. So the definition for this is, if you have mod x, so it should be always positive, right? So if x is equal to, x is greater than 0, x is, let's say 1, you have the same number. You don't have to do anything. So it's x. So if it's less than 0, so if it's negative 5, so you need a positive value. So you multiply it by minus. That is minus x. When x is less than 2, 0. So this is basically the definition of modulus, right? So when you're drawing a graph, so the first thing you need to do is take this modulus term and see, try to equal that to 0. The what is inside to 0. So when x equals to 0. When x equals 0, what is the value of y? Y is equal to 0 plus 1, that is 1. And then next what you do is, when x is less than to 0 case, and then the x is greater than 0 case. So when x is less than to 0, x is less than to 0 means x, this mod x needs to be multiplied by, sorry, x needs to be multiplied by minus. That means y is equal to minus x plus 1. Right? So if the next case is So first, what we did, equal this to 0, then take the case when it's less than to 0, and then take the case when it's more than to 0. So when it's more than to 0, mod x would be x itself, right? Plus 1. So now can we catch this? So when x is equal to 0, this is the x-axis and the y-axis. When x is equal to 0, y is equal to 1, right? So when x is the greater than 0 value, greater than 0, y is equal to x plus 1. So if you have a straight line, the easy way to plot a straight line is just equal, first of all, equal x to 0 and get the y's value, and equal y to 0 and get the x value, and then join those points. So, but this I think it's very simple because it's x, it's similar to the x graph, but just has an intercept of 1. So like what I said before was, we have y equals x plus 1, this is a simple graph. So you make x equal 0. When x is equal to 0, y is equal to 1. When x is, and then you make y is equal to 0. When y is equal to 0, x is equal to, when y is equal to 0, x is equal to minus 1, right? And then, so when x is equal to 0 is this point, and when y is equal to 0, minus 1, and then you just join these two curves, you get the straight line. But if you want, if it's difficult, like if you want to draw a straight line, you can do that. But this is very simple, so you can just draw. This is the curve. So now when x less than to 0, when x is, this is 0, so when x is less than to 0, y is equal to minus x plus 1. So the minus graph goes the other way. So not like this, but like this. Y is equal to minus x plus 1. The same way you did this, you can get the same point, 0, 1, and now it will get 1, 0. So you draw this line. This is the equation for y equals minus x plus 1, y equals plus x plus 1. This is the first graph. Yeah. So we need to sketch both in one. So first we'll sketch them separately and then we'll join them together. Okay. So what's the next graph? Y equals 2. Okay, you tell me. What do we do first? It's time to type this. So what do you do first is you take the value inside the modulus thing and make it equal to 0. So x minus 1 is equal to 0. It means x is equal to 1. So when x is equal to 1, what is the value of y? Y is equal to, that means this whole thing is 0, y is equal to 0. So when x is equal to 0, y is equal to 0. Then you take the two cases. X is equal to 0, now x is equal to 1, so x is greater than 1, and x is less than 1. So when x is greater than 1, that means this, let's put a value. Let's say 5 minus 1 is a positive value. So you get the, it's positive. You don't need to do anything. So modulus value is the same thing. So y is equal to y is just x minus 1. Right? So if it's less than 1, let's put a value and say if x is 0, then this whole thing would be less, a negative value, minus 1. So we need to make it positive, we need to multiply it by minus 1. So y is equal to y minus x minus 1. So if you simplify this, it will be 2x minus 2 and minus 2x. This is minus plus 2, right? Okay. Now, so some person has asked, can't we say x is greater than and equal to 0? This is here, right? No. Yeah, like this line does lie on the when x is equal to 0 as well, but for x is equal to 0, we have a specific point. So we get a coordinate. What we are trying to do is when x is greater than 0, then we are trying to get a line for that. So it's better to write when x equals 0 separately and less than and greater than separately. Okay. So let's catch this. So what's the point? X equals to 1, y equals to 0. X equals to 1, y is equal to 0. This is the point. This is y, This is x. So when x is greater than 1, y is equal to 2x minus 2. So it's similar to this. You have a graph. Now, if you get the points, you will get when x is equal to 0, y is equal to minus 2. So this would be the graph. And y is equal to 2x minus 2. And when x is less than 1, y is equal to minus 2x plus 2. So the same way, this will be 2. When x is equal to 0, y is equal to 2. So you draw this graph with y is equal to minus 2x plus 2. Okay. Now, the important thing to remember here is this. Now, see, you have y equals x plus 1. Now, the coefficient of x, that is the value in front of x, gives the slope of the graph. So if you remember, you can y equals mx plus c form. This m value gives the gradient. What's the gradient? You can write the tan the angle between the positive x-axis and the graph, or the gradient. So when this gradient is higher, the slope increases. So if this is the slope for x, y equals x, that is 1 times, right? This is the slope y equals 2. So the slope of this, the important thing to remember, the slope of this is greater than the slope of this, right? Now, if you are drawing it all at once, you probably might miss it. So that's why it's better to draw it separately and then combine them both, right? So now, is there any question from these two graphs? Like you got these two graphs properly?
The first step is we must substitute x, the thing inside the modulus bracket as 0, right?
Yeah. What's inside the modulus bracket, you make it equal to 0. So here, yeah, we made x equals 0. Here we made x minus 1 equals 0. That means x equals 1. So anything else? Do you get it?
Yeah, understood.
Right. So these two graphs are okay, right?
Yeah.
Someone's asking for the marks for the steps. Oh, yeah. Go on.
You wrote x is greater than 0 and x is greater than 1 in both of the graphs, right? So can't we write it as x is greater and equal to 0 and for the other one greater and equal to 1?
For which step are you talking about? This one?
Yeah.
Yeah, we can write that as well. Because the point where x is, for example, x is equal to 1, this point, but now it's better not to write it because this point x is equal to 1 lies both on this straight line and this straight line, right? Get that right?
Yes.
So it's better, like if you put this value like x equals 0 to here, and here it will satisfy the equation. That means it lies on this line and it lies on this line. So it's better to take x equals 1 as a separate case and greater and the equal the less than case as separate cases, right?
Okay, thanks.
Right. So someone's asked for the marks. So usually for the, like we'll draw it in the next one, but for this, like there are 4 parts here. So for this one, they give 5 marks. For this, they give 5 marks. So the whole question is 25 marks. For this, 5 marks. For this, 5 marks. So that's for the question. So you all got the graphs, right? So now we need to do, what we need to do is draw them all in the same graph, right? Done, right? So draw it here. So x is 1. Remember the slope. Okay. And then 1 here. Now the slope is not the same as this. It should not be parallel. It should be greater than the slope. And we got this point as 2. So we can mark this point as 2. And always remember, put the values for the graphs as well. So this is y equals 2x minus 2, I think. 2x minus 2. So this is y equals, sorry. This is this graph. Y equals x plus 1. This is y equals 2x minus 2. This is y equals minus 2x plus 1, 2. Y equals minus x plus 1. So yeah, that's the first part of the question. We need to sketch those two graphs and then sketch those two graphs in the same graph. So we've done that. And we've written the equation for all the values. So this is this graph, this is this, this is this, this is this. Right? Okay. So you all got that part, right? Any questions? Right. So the next thing we need to do is, the question is hence or otherwise prove the equation.
Excuse me, sir.
Yeah.
So in the previously, you had put like for x minus 1, you had multiplied the whole equation by minus. But what if it's like 0, sir? Because it's x minus 1, right? It's not x minus 0. So
X minus
what if-
0 doesn't have an effect in it. So you are less like this. Is this what you asked?
Yes, sir. Now, example, you had put x minus x is less than 1, right? So it can be any value less than 1. So what if it's a positive value? So why did you multiply that thing by minus?
I'm not sure if I get what you're asking, but what I did was x is equal to minus 1. So when x is less than to 1, it can be positive value as well. So if you are 0.5, let's say, so if it's 0.5 minus 1, that is equal to minus 0.5, right? Still a minus 1. So any number, even if it's a fraction, it is less than 1. If you put this, you could get, it'll get a negative value. So to cancel this negative only, we multiply by minus. Do you get it?
Okay, sir. Yes, sir. Thank you.
Clear, right?
Yes, sir. Thank you.
Okay, so next what we need to do is find the range where this is satisfied. So what is this? This is the first graph here, the one with this slope. And this is the next graph, this one. So we need to find which ranges for x does this graph is where this graph, the value is more than this graph. So which range? So we need to say this graph at what range is this graph greater than this graph. So here you can see it's less than this graph. Here it's less than this. And only in this region, right? This region only you can see this graph has a value higher than this graph. And if it's past this, then it has a less value. So what we need is these two ranges. Range from this to this. Right? So remember, it says hence or otherwise. Hence means whatever you did before, you need to use that to do the question. Otherwise means you can use a separate method as well. So let's do first using the graph. So first we need to do is we need to find what are these points. It is take as A and B. What points? What are the x values for these points? So let's take for point A. Point A. What is the equation of this one? Y equals 2x. Y equals minus 2x plus 2. So this one, don't mix it up. It's still the same graph, right? It's still y x plus 1 is this. So y equals, let's say y dash is equal to x plus 1. From these two, what we can do is minus 2x plus 2 is equal to x plus 1. So if you take x, you can take 2x this side, so it will be 3x. You can take 1 this way. So 2 minus 2x plus x becomes 3x. 2 minus 1 becomes 1. So x is equal to 1 over 3. So this point is 103. So the next we go for point B. So point B, y is equal to x plus 1. I do the second one first. So let's take 2x. So this is the point. So what are the two graphs? Y equals 2x minus 2 and y equals x plus 1. Y equals 2x minus 2. Y is equal to x plus 1. So if you get this together, 2x minus 2 is equal to x plus 1. To simplify, take x this side, 2x minus x becomes x. So minus 2, you can take it to the other side. So minus 2, so it becomes plus 2 plus 1 is equal to 3. So this is the, so once again, what do we need to find? We need to find the equation, so the range or the range of x where this is greater than this. That means this range. We found this. So the area in between is the value. What we need to find. So x is, the answer is x is greater than to 1 over 3 and less than to 3. So that's the answer. And for the marks, this also gets 5 marks. And if you want to be like some people, like it's like a bit cool if you like do it in a different way. So it's like you can do this as well. 1 over 3. So what this basically means is x is an element of the range between minus 1 over 3 and 3. And this bracket indicates it's not equal to 1 over 3. If it's equal, you get the square bracket. So either of these would be the correct answer. So did you get the answer? All right. Seems to be clear. So let me like recap what we did. So what we first did, first they had asked to do us was sketch these two graphs in the same thing. So what we did, we took the modulus value, considered the two graphs. First drew the y equals mod x plus 1 graph, and then we drew the y equals mod twice mod x plus, x minus 1 graph, and then we combine those two in the same graph. And then they had asked hence or otherwise prove this the values for x when this happens. So from the graph we can see this the area range where this graph is greater than this graph is these two areas. So by substituting these values, we can get 1 over 3 and 3. So the range that we need is between 1 over 3 and 3. So that's basically what we did. Tell me more. Right. So they had said hence or otherwise. So if you had done this like this, then you get the full mark. But if you want, you can do it in another method as well, otherwise, because it says otherwise. So I'll do it in that method as well, just to be complete. So we need to prove where this is greater than to this. So we can write this as, we can take the whole thing to one side. So x, not x plus 1. Plus 1 and you minus the whole thing. Minus 2 x minus 1 is greater than to 0. Right? I took this to this side. So we can write this as, let's say, and just an equation, let's say E. Okay. So what we need to do is we need to prove, not prove, but find the values of x where this equation gets satisfied. So here what we need to do is, first of all, the same thing as we did before. Take all the modulus signs and equal what is inside to 0. So here x is equal to 0, here x is equal to 1. And then write them in the ascending order. Right? So 0, 1, the smallest first, the next one next. And then what we need to do is consider the cases when x is less than to 0, and x is greater than to 0 but less than to 1, and then when it's greater than to 1. So these are the cases. And x is less than to the smallest value, and when x is greater than to that value but less than to the next value, then when x is less greater than to this value. So we need to consider these three cases, right? Yeah, someone is asking otherwise method. This is the otherwise method. Let's do it. So like when x is less than to 0. So by the definition, when x is less than to 0, what do we need? What is the value for this? We multiply it by minus, which means is equal to minus x plus 1. Now x is less than to 0. Just substitute a value and say if it minus 1 something, if it minus 1, it will still be minus. So we need to multiply it again by minus. So it's minus 2 multiplied by it's minus x plus 1. Okay, x minus 1. Okay, and this we know is greater than 0. So let's simplify. So minus x plus 1, minus into minus becomes plus 2 times x, 2x, minus into minus once again plus 2 into minus 1, minus 2, right? So if we simplify this, 2x minus x is x, plus 1 minus 2 is minus 1. Now we know this is greater than 0. If it's greater than 0, x is greater than 2. You take 1 this way, x is greater than 1. Okay, but can this happen? We already said x is less than 0. If x is less than 0, how can x be greater than 1? So this is a contradiction. So this is sometimes the simple use of contradiction. This can't happen. So we can ignore this case because x cannot be less than 0 and greater than 0 at the same time. So then we get the next value when x is greater than 0 and less than 1. Now when x is greater than 0, the value of this is x itself. You don't have to multiply the minus again. So it's just x plus 1. But this is it's still less than 1, right? So if it's less than 1, let's say 0.5, let's say 0.5 minus 1 would be minus 1. So we need to multiply it by minus again. Minus 2 into minus x minus 1. Right? So if you simplify this, x plus 1 minus minus becomes plus x, 2x minus 2. This is once again greater than 0. Greater than 0 came from this, okay? Greater than 0. And then this is equal to x, 3x minus 1 is greater than to 0. So x is, you take 1 to the other side and you divide it by this value, 3. So can this happen? Okay, x is between 1 and 0 and x is greater than to 1 over 0. Okay, this 1 over 3. This can happen, right? So this is, we can take as one equation. So last case, if you don't understand, okay. So last case is x is greater than to 1. When x is greater than to 1, x is greater than to 1. This is whole thing would be a positive value. So you put the same value equals just x, not minus x, just x plus 1 minus. Now x is greater than to 1. So if you put 2, for example, 2 minus 1 is positive value. So we don't have to multiply by minus again. We can just put the same value, x minus 1. Now no need minus. Now if you simplify it, so x plus minus 2x, yeah, write it again. X plus 1 minus 2x minus minus becomes plus 2. Okay. So we'll simplify. Minus x, 1 plus 2 is 3. So this is what? Greater than to 0. That means if you take this value to the other side, you can say this is less than to 3. So is this correct? Can we x is less than to 3? X is greater than 1. This can happen, right? So we can take this as equation number 2. Now we have two equations. This we can't consider. So what do you do? We equal each to 0. We consider the cases less than to 0, greater than to 0, but less than to 1, and greater than to 1. And this case we can't consider because it's a contradiction. But this case we can consider, and this also we can consider. So now from 1 and 2, so it will be clearer if you just put x is greater than 1 over 3 and less than 2. Just to be more clear, I'll draw it in number line. So what are the values? 1 over 3 and 3. So x is x is greater than to the first one. X is greater than to 1 over 3. That means it is 1. So it's this area, right? So if it's, and then the next is x is less than to 3. So the area in between is, as you can say, these two areas. X is less than to 3 and greater than to 1 over 3. Or if you want to write in the other way, x is an element of 1 over 3 and 3. So you can do it in this method as well because they said it's hence or otherwise. But if they don't say otherwise, you must use the first method as well. first method only, right? Even if this is correct, they won't give you marks if they have said hence only. So any questions about this? If you understand, just put clear yes or something. Right, got it, right? Okay, what's the time? 8, right? We're still in the second test. Okay, let's go to the next one. The next question. Somebody has put 8. Okay, can hear what I say, right? Okay, so the next question. So this is the next question. When sketch on the same argon diagram, the locus of points representing the complex numbers Z satisfy the modulus Z minus I equals 1 and argument Z minus I equals 5/6. And find the complex number represented by the point of intersection of those two in the form of r cos theta plus I sin theta. It looks very complex when you see it, but it's not that complex. So, right. So the first thing is sketch on the argon diagram locus. Now stop this. It's given this question number 3. Z minus I is equal to 1. So the theory you need to know to draw this is this. So if you have now a complex number is this, simply Z can be written as x plus I1. What's the complex number? It just means like it's a number with this I value. What is I? I is equal to root minus 1. So we can't represent this in a normal diagram, so we call it a complex number. So this is a complex number. So what this represents is Z minus Z naught. So let's take Z naught as another complex number. The modulus value represents the distance between. Okay, I'll draw it to be clear. So if you have something like this, what this means is there is a complex number Z, there's a complex number Z naught, and the modulus value is equal to R. So what this represents is a point or a circle. Z lies B and Z, right? The locus of Z is a circle, right? The center is this one, Z naught. And the radius is R. So this is basically what it means. If you have something like this, the locus means the modulus Z minus Z naught equals R. That means Z lies. So Z lies somewhere on this circle, and the center point of the circle is Z naught. So if Z naught is equal to x naught plus IY naught, this point would be x naught, Y naught. Right? So that's basically the theorem. So can we apply the same thing here? Z minus I is equal to 1. So this represents Z minus Z naught, right? So this represents a complex number. We can say 0. They haven't got an x term, so it's 0 plus I1, right? So what is the coordinates of this? So coordinates are always x naught, y naught. That means 0. The y value here is 1. So there's no y here. Y is equal to 1. So 0 plus I. So this is 0, 1. So what does this represent? If this represents this represents a circle. My circle is not really a circle, but it's okay. With the center points 0, 1. This is the center point 0, 1. 0 means x coordinate, 1 means the y coordinate. So this is the x axis. No, there's no x axis and y axis in argon diagram. So argon diagram is basically normal, like it's a diagram that represents a complex number. So this would be the x part actually represents the real part of the of the complex number, and the y part represents the complex part, the imaginary part. So we call it the real axis, and this would be the imaginary axis. Okay, so I hope you can see my circle here. So 0, 1, this is, and what's the distance it represents is equal to 1. The radius is 1. Okay? So that's the first thing they have got. What's the next thing? Argument of z minus, I'll erase this part. Argument of z minus I is equal to 5 by 6. So what does this mean? So the theory behind that is, now what is an argument? Argument of z is equal to theta means it's basically like if you have the real axis or if you have horizontal line, this and z is represented here. This angle between the real axis and this is called the argument, right? The argument of z is theta. This is how we represent it. So if you have this, then argument of z minus say z naught is equal to, let's say, alpha. So what this means is the point where, once again, like similar to this, you get the like the center or the starting point is 0, z naught, and then the horizontal line is this. So z lies. So what this means is z lies on this line, which is at an angle or the argument alpha from the horizontal line. So this is basically what this means, right? So this is the same thing. So what is this point? 0 naught. We already found it. That's 0, 1. So we can, if you want, you can draw this straight line. So z lies on this line where this angle is 5 by 6. So I'll just erase this because I'll put here as 1, so it will be clearer. So now z lies on this angle is given as 5 by 6. Clear? This angle, this is, I represented this in the same diagram, 5 by 6. Okay. Now, an important thing you have to note is this point is not included. So you need to make sure you draw a circle like this, because it shows that the point z naught is not included. Because say, for example, z is equal to z naught. If z is equal to z naught, then you get something like 0. So argument of 0, so it won't be undefined. So remember to put like it's not equal to this point. So put a circle here, small circle like this, and then only draw this. Okay. So now what they have asked us to do is we need to represent z in the form r cos theta plus I sin theta. So you also know that z equals x plus I y, but it can also be represented in another form. That is r times cos theta plus I sin theta. Okay. Now, what is theta? What is r? R is basically the distance from the origin to the z. So where is z now? Z is at the intersection of these two locus. So this is the first one. Z lies on this one, and the next. So that's what they said. The next one was this. So it said Z lies on this line. So where is Z? Z is at the intersection point. This point. This is where Z is. So we need to represent Z in that form. So if I take this point as P, let's consider this as O. Let's consider this as A. If I can find that R is what? The distance from the origin to this. So this value, right? If we can find OP, R is OP, right? OP and cos theta. What is theta? Theta is, once again, as I said, if you have Z here, the value, the argument of this complex numbers. So this value is the angle we need to find, theta, right? Okay. So first, let's find the angle. Now we know that this is 5 by 6. 5 by 6, okay? 5 by 6 means what? 30 degrees. 5 is 180. So if this is 5, this we know this is also 1, this is also 1, this is an isosceles triangle. So these two angles are same. We know this is 90, as you can see. So 90 plus 30 is 120. And the angle in a triangle is 180. So that means these two, the sum of these two values are 60. That means 1 is 30. Okay, right? This is 30, 30 plus 90, 120. Whole thing is 180. That means one of these angles is 30 or 5 by 6. So if this is 30, what is this angle? 90 minus 30, 60. Or you can write 5 by 3. So we just found theta, right? Theta done. Now what do you need? We need R. So what is R? R is this distance. We know this distance. We know this distance. We know the angle between these two as well. So can we find R? Yes. So let's say OP. OP is this angle. This distance is equal to OA. OA cos. If towards the angle cos, away from the angle sine. So towards the angle cos 5 by 6 plus this plus this. Okay. AP cos 5 by 6. Okay. OA is equal to 1. That's the radius of the circle. This is also 1. Cos 5 by 6 is how much? Cos 30 is √3 over 2. Plus cos 5 by 6 is √3 over 2. So OP is √3. Why is OP? OP is the R distance. So we know R, we know theta, and we can just write the value of this Z as Z is equal to what is R? √3 cos. What is theta? Just found it. Where is that? 5 by 3 plus I sine 5 by 3. This is the answer that they. So did you get it? Is it clear? If it's clear, just put it. It's clear. Otherwise, I don't know if you understood anything or you don't understand anything. So basically, what we did, go back again. So they gave this. This represents, as I said, Z minus a circle whose center is this, and Z lies on that circle, and the radius is this value. That is 1. We drew that. Argument Z minus 1 is the same thing, similar thing. Where this with this center, the Z makes an angle 5 by 6 with the horizontal line. And remember, don't include the this point because they cut marks for that, given in the marking scheme. So don't include this. And then we found that Z lies on this, Z lies on this. That means Z lies exactly here. So to write it in that form, we need the angle between the Z and this, the argument, and also the distance. So we found that the distance was √3. The angle was 5 by 3. So we wrote this equation, wrote this complex number as Z equals √3 cos 5 by 3 plus I sine 5 by 3. Right. Let's move. Maybe we'll take a break or something at maybe question number 5 or something. Otherwise, you are like, these guys just keep going. Okay, fourth one. So fourth one is an easy question. Very question. So how did you get the center of the circle? I'm not a sir, by the way, I'm just a. So how did you get the center of the circle? Is there a way to identify whether is the diagram a circle or a line? So is it Z minus Z not. If it's in that form, then obviously it's a circle. Z minus Z. There's a theorem. You can like refresh your theorems on the complex numbers. So if it's modulus Z minus Z naught equals the modulus Z minus Z naught equals a certain value, that means that's a circle with the radius R, and the Z naught is the center. That's how you identify whether it's a circle or a line. You have 5 numbers. So how many numbers can you form? So for the first, if you have 5, you can first select how many ways you can select the first one number. It's 5. How many ways you can select the second number? It's 4. So if you selected already 1, that means you have 4 remaining. So 4. Now you selected 4. You can then ways you can select the next number is 3, 2, 1. So the total number that can be formed is 5 into 4 into 3 into 2 into 1, or factorial 5. That is 120. Okay. So the next thing they're asking is how many of these are even numbers. So how do you form an even number? So to form an even number, there's only one condition. The last number should be even, right? If this number is 2, 4, 6, 8, which is an even number, then the whole number is an even number. So out of these numbers, what are even numbers? 2 and 4. There are only 2 even numbers. So how many ways can you select this last digit? There are only 2 even numbers. Therefore, the ways you can select that number is 2. So now we selected a number. So how many numbers are remaining? 4 numbers. So how many ways can you select the first number? 4. How many ways can you select the second number? 3, 2, 1. So the answer, the number of even numbers is 4 times. So, but you can have it both and 3 mixed up as well. It would also be factorial. The answer is factorial 4 multiplied by 2. Factorial 4 is all 24. This is the number of instances where 3 and 4 are together. So first of all, they have asked how many combinations can you do. So 5 into 0.3, so factorial 5 because there are 5 numbers. So you get 120. Then they ask how many even numbers. For the even, for the whole number to get even number, the last bit should be even. So it's 2. And then 4, how many can you select the next number? 4, 3, 2, 1. If you multiply, you get 48. If 3 and 4 are together, you consider this as a separate or as one entity, and then you get the value. You know, Okay, I'll keep going, and if there's a problem, can you say? So, did you get this? Did you understand this question and the answer for it? Yeah, I think the mic is a bit far. Did you understand this? I'll explain again. One. Okay, so there are 5 numbers: 1, 2, 3, 4, 5. And how can we arrange those numbers? So there are 5. There are the ways we can say the first number is 4, 5. The next number 4, 3, 2, 1. That means factorial 5. So if you multiply all of them, you get 120 ways or 120 numbers that can be found. So then they have asked number of even numbers that can be found. So for even numbers, the last number should be even. So there are only 2 even numbers here. So the last number is 2. And then you multiply by 4, 3, 2, 1. You get the answer 48. And if you, the next question is, when 3 and 4 are together, how do you get it? So when 3 and 4 together, let's consider this as one separate thing. That means there are only 4 numbers. Therefore, it can be 4 factorial 4. So, but 4 and 3 can also be 3 and 4. Like 3 and 4 can be also be 4 and 3. So that's also factorial 4. So there are twice factorial 4. The answer is same as this 14. So that's basically the question. Shall we take a break and come? Can we break? 5 minutes? Alpha is greater than 0. Find the value of alpha such that this equation is equal to 16. So we need to find value of alpha. We have already been given. So they have given limit x tends to 0. That's right. 4 plus x squared. Equal to 16. So what we need to find is we need to find alpha. So how do you do this? Now why? Now we need to first simplify. So why did we have to simplify it first? Because what is now, just put x equals 0 and see what will happen. If x is equal to 0, this whole thing becomes cos 0. If cos 0 is 1. So 1 minus 1 is 0. So if you put x equals 0 here, that will be root 4 minus this also will be 0. So root 4, we get 0 divided by 0. It is undefined. That's why we can't just substitute. We need to simplify it first and then only substitute x is equal to 0. Okay. Whenever you have this, when you see this root something minus root something. So to get rid of the root, the easiest way to do it, multiplied by its conjugate. So do that. So if you have a minus b into a plus b, that is equal to a squared minus b squared. So with that, we multiply by the conjugate of this or conjugate, then you instead of minus, you put plus. You do this, you will get this. So you can square this and the square root of it cancel. 1 minus cos alpha. There are 2 ways you can do this. One, because whenever you see this one thing and you have cos, you can cancel this 1 by substituting for cos alpha. That is the cos 2x formula. So cos 2, let's say cos 2 theta, that will be written as 2 times square theta minus 1. Or it can also be written as 1 minus 2 cos square theta. Whenever you have this 1 minus thing, we can substitute one of these things so that we can cancel this 1 off. So for example, here we can put 2 sine square theta minus 1, sorry, not that. If you put this, minus minus will become plus. So we need to cancel this, so we can use this. If you put 1 minus 2 cos square theta, here this 1 will cancel. So that's one way you can. Another way you can do it, also multiplied by the conjugate of this. 1 minus cos alpha x, you multiply by 1 plus cos alpha x. That will give you 1 minus cos squared alpha x. This is actually sine squared alpha x. So those are some of the methods you can use to simplify. So let's do it using, let's multiply both by the conjugate. So 1 minus cos alpha x multiplied by 1 plus cos alpha x. And if you are doing something to the top, you need also do it to the bottom. And the same thing we do for this. Okay. So that's basically your future data. So limit x tends to 0, 1 minus cos alpha x. So what I'm doing is I'm multiplying this whole thing by the conjugate of this. 1 minus cos alpha x is 1 plus cos alpha x. If I'm multiplying something by the top, I also need to divide it by the bottom. So 1 plus cos alpha x. And I'm also multiplying by the conjugate of this. That is root 4 plus x squared, not minus, but plus. Okay. 4 minus x squared. Right? Okay. So if we multiply this, what would be the answer? First of all, 1 minus cos alpha x into 1 plus cos alpha x. What is that? 1 minus cos squared alpha x. Okay, 1 squared is 1 squared. So 1 squared minus cos alpha x. Okay. So this and this is done. So then you have this. So I'll take this first, 1 plus cos alpha x. No, so this and this, if you multiply the root, square root cancels out. So it will be 4 plus x squared minus 4 minus x squared. How did I get that? So a squared minus b squared. So a is this root thing, you square it and then minus b squared. Get this. Okay. So this is done and this is done. So these are the remaining terms. This top part and this top, this bottom part. Root 4 plus x plus root 4 minus x squared. And plus cos. Okay. So this is also done. This is also done. So like sometimes mark this stuff because you can, if you miss one step, you might like end up wasting a lot of time doing the. Oh. Okay, so 1 minus cos squared alpha x. Do you know the sine squared theta plus cos squared theta is equal to 1, which means 1 minus, so sine squared theta can be written as, if you take cos squared theta to the other side, 1 minus cos squared theta. Isn't it the same thing here? 1 minus cos squared alpha x. So that can be written as sine squared alpha x. So I'm writing here. This top part is sine squared alpha x. Now, what is this? 4 plus x squared minus this minus. Can anything be cancelled? Okay. Now, when I do this, if I simplify this, I probably make a mistake and cancel off all the x squared. So the mistake is I forgot to put the brackets here, right? So these simple mistakes, if you make, you might end up spending a lot of time trying to figure out what's the answer. So it's 4 minus the whole thing, the minus applies to the whole thing, okay? Otherwise, if you just put it like this, you'll cancel the wrong thing. So minus 4 plus 4, we cancel these two. X squared minus minus becomes plus x twice x squared. Now multiply this by the same. Now let's just put x equals 0 and see x equals 0 and see what happens. So if x equals 0, this sine 0 becomes 0, This also becomes 0. Therefore, this is still under. So, but this one is this becomes 0. We can add this to plus 1 plus 1. So there would be no problem. So the issue is this. So for that, you probably remember the theorem. That is limit. We have the limit x tends to 0. Sin x over x is equal to 1. So this is 0. This you can use this. Can you use this here? Almost the same thing, right? Sin alpha x squared. So we need to sort of make it the same. So this should be the same thing here. So limit x to 0. Sin alpha x. We need alpha x down. So sin squared alpha, it should be alpha squared or alpha x squared. So I put alpha squared here, but I can't just put alpha squared, so I need to cancel this as well. So 1 over alpha squared. Okay. So if I do this, sin squared alpha x divided by, I keep these two terms, alpha squared x or alpha x perfect square. Okay, these two, and 2 into, write these two here, 2 over alpha squared x. So it's in the bottom. To get the reciprocal, it will be alpha squared over 2, right, into this term. I'll write the limit outside as well. So limit x tends to 0, root 2 plus x squared plus root 4 minus x squared. Oh, okay. Right. So what is this? It's the same thing as this, right? Sin x is the, if you write the square outside, sin alpha x square by alpha. Now also remember, this is like, look at this, sin x divided by x. The same thing here, and x tends to 0. So here x tends to 0, but this is alpha x. But if x tends to 0, alpha x also tends to 0. Why? We multiply any 0 by any value, this will be the same value, 0, right? So this is equal to 1. What is alpha squared? We don't know. Into alpha squared over 2. Now we substitute 0 here. If you put 0 here, it will be 0 here, it will be 4. Root 4. This also root 4. Root 4 is 2. 2 plus 2 is 4. Multiplied by 4 over, what is x0? Cos is cos 0. Alpha into 0 is 0. So cos 0 is 1. So this is 1. So can we get the answer now? There's something we missed.
Equals to 60. Use that.
Yeah, I think there's a small mistake here. There's a 2 missing. All right, sorry. So cos alpha x, cos is 1, right? So 1 plus 1 is 2. So this should be 2 here. Okay. 2 into 2 is 4. 4 can cancel this off. So that is equal to alpha square. Okay, so erase this part. All right. So this part is the left side of the equation. So as you can remember, the limit thing is equal to 16. So we simplified the limit section to make it alpha square. Okay. If it's alpha square equals 16, what is alpha? 4. Why is it 4? Because always remember, if you get the square root of something, it should be plus or minus, right? Plus or minus 4. But because it's given, if you look at the question, it says alpha is greater than 0. So you put in brackets alpha is greater than 0. So we get the answer. I'll explain what we did again. So we have been given this equation. Limit x tends to 0, 1 minus cos alpha x divided by this is equal to 16. So we need to find alpha. So what? Sorry, you couldn't see it, right? Okay, you need to find alpha. So what we do in this question is we multiply both the top and bottom by its conjugate. So 1 minus cos alpha x, 1 plus cos alpha x, 1 plus cos alpha. And then you multiply by the conjugate of the denominator. Plus you multiply. So this two can be simplified as 1 minus cos squared alpha. And these two can be simplified as this version. Remember the bracket, so you can simplify correctly. And then you get 4 plus x this. And then you get because 1 plus sine square theta plus cos square theta equals 1, we can simplify this as sine squared alpha x, and you can get this and this. But we still need to simplify this. So we use this theorem. We need sine x divided by x equals 1, and you simplify it in that form, and then you get alpha squared divided by 2 and this. Now we can substitute because it is 1. When we substitute, we get alpha squared. So this equation can be simplified as alpha squared. But we know that this equation is equal to 16. That means alpha squared is equal to 16. That means alpha is equal to 4 because it is given that alpha is greater than 0. Okay, any question? Right. It's clear. Let's move on to that. If you have any problems, just stay there before I read it. An integration question. So we need to find the area that of the region enclosed by the curve y equals x and x squared and 2x minus x squared. Is it? So first we need to draw this two. All of the equation of for y equals x squared. Simply this. What you do is you complete this one. Before completing this one, you can see this is minus. So I just take the minus value out. So it will be more clearer to do it. So let's take y minus minus. So it will be x squared minus 2x. Right? So how do you complete? So I took the minus because it's more familiar with the positive thing. X squared minus 2x. You take the first write x, then you write this value, the coefficient of x, half of that. What is half? Minus 2 minus 1. You square it. Now you square it, another x squared, then this into this multiplied by 2. That is minus 2x. Okay, x squared is okay, minus 2x is okay, but there's also an additional term, minus 1 square. That is in you subtract that. Y equals y equals draw the graph. So the coefficient of the sign of the coefficient of x squared shows whether this graph is a minimum graph or a. So what is the minimum graph? When the graph is like this, it's a minimum graph. It has a minimum point. The maximum graph is when the graph is like this. The coefficient is positive. So that means it's a minimum graph. Like this. Because here the coefficient is negative, it's a maximum graph. Graph comes like this. What is this point? So y is a maximum graph. So y is maximum. Y becomes maximum, then this value becomes minimum. Even if the inner value is a negative value or a positive value, because it's a square, it will always the square of this will be a positive value, right? So if it's positive, it will is equal to 0. Okay. This is negative or positive, it will always be a positive value. So we need a minimum value of the value inside this is equal to 0. So value inside is equal to 0 when x is equal to 1, right? When x x is equal to 1, how much is y? Substitute here. So what is this value? This is the value of the maximum term, 1, 1. Actually, maximum graph, we can, like, when x tends to plus infinity, where is y go? So plus infinity, this whole thing becomes multiplied by minus, y goes to tends to positive infinity, y tends to minus. X tends to minus infinity, minus square will be plus, that is infinity square, that is also infinity plus infinity, and the whole thing by minus, it will be minus infinity. Y will go to x goes to minus infinity, y also goes to maximum graph. Maximum points is 1 and 1. Okay, so if we draw both of the graphs in the same graph, so we have y equals x squared here. What is the point? It's 1 and 1. So if I consider this, okay. Now we need to find what are these points? Where does this to cross the line? So how do you find that? This is when x, this is y, this is x. When x is equal, sorry, when y is equal to 0, we can find this value. So substitute y is equal to 0. When y is equal to 0, 2x minus x squared is equal to 0. So can somebody unmute themselves and say if I'm audible or not?
Yes, sir, you're audible.
So we can.
If you can't, just okay. So what I said was before was if you want this area enclosed by these two curves, so if you take this curve, this is the distance y2 from the origin. This is the distance y1 from the origin to the bottom curve. So what is this distance? The area enclosed by them. That is actually y2 minus y1, right? So in the same way, we can get the top graph. That is y equals 2x minus x squared, okay, minus this bottom graph, y equals x squared. And we can integrate it. Why integrate it? Integration can be thought of as summation. So if you can take this part and you sum the whole thing from this point to this point, if you get this small value, small area, and you sum the whole thing, you get the entire area from entire area between. So that's how we get it. So, but for that, we need to know which points are these. What are these points and what are these points? We already know this point is equal to 0. So what is this point? So for that, we equal this y equals 2x minus x squared and y is equal to x squared. If you equal these two, we get the answer. 2x minus x squared is equal to x squared. So if you get both of them to the same side, 2x minus x minus becomes 2x squared is equal to 0. So if you take 2x out, or you can just cancel 2, right? Because it's 0. Then if you take x out, x minus x out, you get 1 minus x is equal to 0. So this is equal to 0, this is equal to 0. Therefore, x is equal to 0 or x is equal to 1. So we got x is equal to 0 here, x is equal to 1. It's this point, right? So now we know the integration needs to be done. y2, what is, I consider this as y2, it says y1, okay? So y2 minus y1, you integrate with respect to x from where to where? From this position to this position. 0 to 1, right? So I'll erase this part. Y2 minus 1. What is y2? Y2 is this value. So 0, 2x minus x squared minus, what is y1? X squared. The whole thing you integrate with respect to x from 0 to 1. Right? Now, if you simplify this, you get 0 to 1. 2x minus x square minus, so it's 2x minus y is x square dx. Okay, so we can take the 2 outside. 0 to 1, x minus x square dx. Okay, how to integrate? So to keep 2 outside, when you integrate x, what is the integration of x? Is x square over 2. Y x square over 2. So if you differentiate x square, they get 2x. Cancel that 2, we divide by 2. So x square divided by 2 minus x square, if you integrate, it will be x cube divided by, you add 1 and divide it by that one. Right? And from what value does it go? From 0 to 1. So what do you do now? You substitute the higher limit and get the value, and you subtract it from the lower substitute. So the answer is 2. What is x? So you substitute 1. It is 1 over 2 minus 1 over 3 minus. Now you substitute 0. Okay, 0 minus 0. Okay. So this is 0. You don't need to consider this. So 2 into 1 half minus 1 over 3. I did here. All over the table. So so multiply this by this 3. Multiply this by this is 2. 3 minus 2 is 1. That's 1 over 3. 1 over 3 into 2 is 6. Multiplied by 2. Okay. 3 minus 2 is 1. Divided by the multiplication of these two values, that is 6. The value is equal to 1 over 3. Now what did we find? Is the area enclosed by this two circles. So this area, so we need to write this square units. Do you understand? Is it clear? So we had to find the area enclosed by two curves. We drew both the curves and the area enclosed. We got the top curve and subtracted that value from the bottom curve, and we integrated from y integrate because we want to get the summation from 0 to 1, 0 to these two the points. And when we substituted and simplified, we got this answer, and the final answer is 1 over 3 square units. So if you're clear, you can just unmute and say this clear or something. Going on to the next question. So a curve C is given by the parametric equations x equals 3 sine square theta by 2, y equals sine cube theta. And we need to find that dy by dx is equal to this. And if after we find that, we are going to find the gradient of the tangent at the point P, this find value of theta. So first of all, we need to find dy by dx. So we need to find dy by dx. Now we haven't been given y and x, y in terms of x, right? We given x in terms of theta and y in terms of theta. So we can use the chain rule. What we do, dy by dx can be written as dy by d theta multiplied by d theta by dx. Right? So if we can get dy by d theta or dx by d theta, then we can substitute to this equation and find the answer. So First of all, let's differentiate this with respect not to x, not to y, but to theta. How do you differentiate this? So first, we keep 3 and then sine square theta. Distance is x squared. Well, how do you differentiate? It becomes 2x. So sine square theta, if you differentiate, it will be 2 sine theta by 2. That is the x squared. So then what we need to do is this integrate differentiate sine theta by 2. So when you differentiate sine theta by 2, that is cos theta by 2. Once that is done, so now the squared is done, the sine is done, now the value inside theta by 2. When you differentiate theta by 2, the answer is with respect to theta is half. Remember, is half. I think most people forget the half because we are not just sine, we are doing the square and then the sine theta and then the value inside the theta. So you get the half. Okay. So this can be written as half and 2 can be cancelled out. So it will be 3 sine theta by 2 cos theta by 2. So next we need dy by d theta. Okay. So say consider like x cube. If you differentiate this, it will be 3x squared, right? So similarly, it will be 3 sine squared theta. Now you differentiate what is now the cube is done. Now the next step is sine theta. If you differentiate with respect to sine theta, it will be cos theta. Now cos theta is done. What's inside is theta because it's just theta. Then it will be just 1, half 1. So now what do we need? We already said we need dy by dx, but we have got this. But using this, we can get this. So dy by d theta dx can be written as dy by d theta multiplied by d theta by dx. So what is dy by d theta? This one, we find it. 3 sine square theta cos theta. And the d theta by dx. So this is dx by d theta. D theta by dx is the reciprocal. Or you can say you can divide it by this value. 3 sine theta by 2 cos theta by 2. Right? So 3 and 3 you can cancel out. So sine theta by 2, cos theta by 2. What formula do you remember that we can use to simplify this? So if you remember, sine 2x can be written as 2 sine x cos, sorry, sine 2x can be written as sine 2x cos x. Sorry, sine x cos 2 sine x cos x. Okay, sine 2x can be written as 2 sine x cos x. Okay, we can use the same formula here. So we need a 2. So for that, I'll multiply this by 2 because I'm multiplying the bottom by 2. I should also multiply the top by 2. So what is this? 2 sine theta by 2 cos theta by 2. Using this formula, can get sine theta, right? Multiply this. What's inside by 2 sine theta. Now can we cancel this off with something in the top? Yes. So sine theta and then the square can be cancelled. Okay. So what is this? So 3 cancels off. 2 already becomes this. So what is remaining is 2 sine theta cos theta, and from the same sine 2 theta formula I said before, we can write this as sine 2 theta. So basically, that's the first part of the question. We've been given x, we've been given y in terms of theta. We need to find dy by dx, but first we find dx by d theta, dy by d theta, substitute them and simplify them. We get the answer sine 2. The next part, 3 questions. Right. So the next part of the question is, so there's a curve C, and at the point P, the tangent value is, the gradient is here. So what is the, now if you know difference, what is differentiation? So if you have a curve, and if you differentiate this point, a particular point, you will get the gradient of that point, or actually the tangent, the gradient of this point. Okay, this is the value you will get if you differentiate this. So they have already given us that the gradient of a point P in the curve C is this. So what is the gradient? The different derivative, right? That is dy by dx. So dy by dx at point P is given. What is it given as? 2 CO2. But we already know what dy by dx is. Right? We just proved it in the previous thing. That is sine 2 theta. So sine 2 theta is equal to root 3 by 2. So what they're asking is, what is theta? So sine 2 theta is equal to root 3 by 2. And because this is positive, we have been given that excess. So theta is less than pi by 4, greater than 0. That means 2 theta is less than pi by 2. That means it's in the first quadrant. Okay, so everything is positive. So root 3 by 2, we can directly say, because it's in the first quadrant, we can say 2 theta is equal to, at what point does sine 2 anything becomes root 3 over 2? It's in sine 60. What is 60? Pi by 3. Okay. If 2 theta is equal to pi by 3, theta is equal to pi by. Right? Check it. Few more questions. Let's see. Okay, let's move on to the next question. Right? It is a straight line that passes through the origin. Start from the 8th question. Let L be the straight line that passes through the origin and the point of intersection of the straight lines 2x plus 3y minus k equals 0 and x minus y plus 1 equals 0, where k is not equal to 0. So we need to find the equation of L in terms of k. And then the next part is they have given 2 points that are on the same side of L. We need to show that k is less than 20. The first thing we do is they say there's a straight line that passes through the intersection point of 2 straight lines. So the theory here is, if you have 2 straight lines, let's call L1 equals 0 and L2 equals 0. So L1 is in the form ax plus by plus c equals 0 in this form. So if you have two straight lines, the equation of the straight line that passes through the intersection point of this straight line can be written as L1 plus lambda times L2 equals 0, where lambda is just a parameter. Can be any number. But this gives you a set of straight lines, not one straight line, but a lot of straight lines. So, and then the next thing we can use is they have given 1 point that this the straight line passes through the origin. So using these two, we can find exactly which straight line we need. So as they have given the two straight lines, 2x plus 3y minus k and x plus y minus k equals 0. So the equation of the straight line we need is 2x. We will substitute this equation: 2x plus 3y minus k equals minus k plus lambda times x minus y plus 1 equals 0. Now they have asked the question in terms of the equation of the straight line in terms of k, but we have a lambda here. So how do we get rid of the lambda? We can use this the theory that the point that this straight line passes through the origin 0 0, which means the value 0 0 satisfies this equation. So let's substitute. So this is 0 plus 0 minus k plus lambda times 0 minus 0 plus 1 equals 0. So what I'm doing is just substituting. or just to make it clear, where x is there, I substitute 0, where y is there, I substitute 0. So if all of these are 0, so we can say minus k here plus lambda times 1 is equal to 0. So lambda is equal to k. Now we found the value of lambda as well. So we can find straight away write the equation for this as 2x plus 3y minus k plus what is lambda? We found that lambda is k is x minus y plus 1 is equal to 0. So we can simplify it further. We'll take the x together. So x be 2 plus k. And then we take the y together. That is 3 minus k minus multiplied by minus. So minus k plus k will cancel out. This will cancel out with this. So this is the final equation that we need. The equation of the straight line passing through the intersection points of this straight line and the origin. So what did we do? First, we have two straight lines, and the equation of the line passing through the straight lines can be got as L1 plus lambda L2 equals 0. This is a set of straight lines. So this is the equation. We also know this line passes through the origin, 0, 0 point. By substituting this, we can find the value of lambda, which is k. So by substituting the lambda equals k in this equation, we got the final equation. X 2 plus k into 2 plus k plus y 3 minus k is equal to 0, which is the equation that we need. Right. So moving on to the next part. So the next part has said that there are 2 points lying on the same side. They have given two values, 2 points lying on the same side of the straight line. So the theory we need for this is this. If there are 2 points, let's say P1 and P2. P1 can be written as, let's say, just x1, y1. P2 is x2, y2. So if these two lie on the same side, so this is the equation, the theory, ax1. So if you have a line, say L1 equals ax plus by plus c, if you substitute this value x1 plus y1 and you multiply them like this in this form, ax1 plus by1, substituting x1 y1 here plus c into ax2 plus by2 plus c. So when you see and at this value, so if these 2 points lie on the same side, the value of this is greater than 0. If it lies on the opposite side, the value is less than 0. So for this question, they have said the points 1, 1 and 3, 4 lies on the same side. So let's substitute these 2 points for this, and because it's on the same side, we can say that the values are greater than 0. So what is the equation of the straight line? We just found it, x into this. So what we need to do is substitute this value. The values they have given is 1, 1 and 3, 4. So P1, let's say P1 is this, and P2 is 3, 4. Let's substitute. So substitute to this equation, okay? So x, instead of x, I put 1. Instead of y, I put 1. So 1 into 2 plus k plus what's y, also 1, into 3 minus k. So this is the first one. First part, I substituted this value. Now in the next, I need to multiply this by the same equation. Now I need to substitute x2, y2. That is 3 and 4. Same equation. So that is 3 here, 2 plus k plus y times, what is y? 4 times 3 minus k. Is it? No. We have said lies on the same side, which means this whole thing is greater than 0. Okay, so so this is 1 times k is k, 1 times minus k is minus k. So this k cancels out. This is 2, 3. So the answer here is 5. Here, 3 times 2 is 6. 6. This is 4 times 3 is 12. 6 plus 12, 18. 3 times k is 3k minus 4k. 3k minus 4k is minus k. Minus k. This whole thing is greater than 0. So 5 is obviously greater than 0, which means 18 minus k is greater than to 0, which means k, if we take the k to the next side, here's this part, k is less than to 18, which is the answer we need. So once again, what do we do? We have, the theory is this: if we have 2 points and you substitute these 2 points to the equation, if you multiply it in this form and the value is greater than 0, this means the 2 points lie on the same side of the straight line. So what we do here, we substitute those values, and when you substitute to the equation that we found before, we get 18 minus k is greater than 0, and by that we can say that k is less than to 18. So that is the answer for the 8th question. Let's now move on to the next question. So the next question is this: that A, you have given A and B 2 points, and S is a circle, and AB is the diameter. So we need to find the equations of the circle first, and then we need to find the circle with center this, which intersects S orthogonally. So what do you do for that? So this question number 9. Now, what they have said is there are 2 points A and B, which is the diameter of the circle. A and B is given as 1, 1, 2, and minus 5, 4. So we need to find the equation of this circle. So how do you find the equation? There's theory for this. So if you have been given the 2 points on the circle, on the diameter, let's call this x1, y1, and let's call this point x2, y2. And if you draw, if you can remember from order, this is a semicircle angle. This is 90 degrees. So the theory, and if you use this point as xy, the theory is you can write the equation of this circle in this format. Okay, I think you can write the equation of the circle in this format. Y minus y1 divided by x minus x1 multiplied by y minus y2 divided by x minus x2 is equal to minus 1. This is the theory. I think you proved it in the straight line section. You must have proved this equation. If there are two lines that are perpendicular to each other, the gradients multiplied will give minus 1. So by using this equation in this sum, we can find the equation of the circle. So here x1, y1 is, let's say x1, y1 is equal to 1 and 2, this point. And here x2, y2 is minus 5, 4. So let's just substitute y minus what is y1, 2, divided by x minus what is x1, 1. Multiply this by y once again minus what is y2, 4, x minus x2. Minus x2 is minus 4. Minus 5, sorry, minus 5. Minus 5 can be written as plus 5. Right? This is equal to minus 1. So if you simplify y minus y2 into x minus, sorry, y minus y4, y minus 4 is equal to minus x minus 1, x plus 5. So let's simplify this. Y into y is y squared. Minus 2y minus 4y is minus 6y. Minus into minus becomes plus. 2 times 4 is 8. So we can take this whole thing to the next side, which makes it positive. So plus, if you simplify this, x times x, x squared. So plus 5x minus x. If you add them, it will be plus 4x minus into minus plus, sorry, minus into plus minus 1 times 5 is equal to 0. So what I did was I took this whole thing to the next side, which makes it positive, and I simplified the equation for this inside. So you get this. So now you just have to simplify. So if you can remember, the format of circle is usually x squared plus y squared plus 2gx plus 2fy plus c equals 0. That's the normal format you have to circle. So here s is equal to x squared plus, what is what? Okay, y squared, x squared done, y squared done. So then plus 4x minus 6y plus 8 minus 5, that is plus 3 is equal to 0. So this is the equation of the circle. This is the equation of the circle, which has the diameter 1, 2, and minus 5, 4. I hope you understood that. So what's the next part? So next they have said there's a circle that intersects this circle orthogonally. Now, what does it mean to say a circle intersects orthogonally? So I'll keep this. This is the equation of the circle we have, which is S plus this. Now they say there's another circle, let's call it S dash, that intersects this circle orthogonally. So what is meant by orthogonal is this. So if you have two circles, sorry. You have two circles and say this is the center of this is the center of this. If we draw line like this is perpendicular, then we say that these two circles intersect each other orthogonally. Now, what is the theorem that we can use to represent this? Now, first of all, you might, as I said before, the normal format of a circle is this: S is equal to x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Okay. So the center points normally we represented by minus g minus f. So if this is the format of circle, the center point for this would be minus g minus f. Now let's consider this as the circle we find from, this is S, what we knew before. So there's another circle they say, let's call it S dash, that intersects it orthogonally. Now what would be the coordinates of the center point? We've already been given it, but I'll write it in this form, g dash minus f dash. So we need to find the equation of this circle, S dash. So we know g, we know f, but we don't know c. So how can we find c? Right? So the first thing we need to do, when they say there is a circle that intersects another circle orthogonally, we need to remember this equation. There's a 2g dash plus 2f dash is equal to c plus c dash. So we have two circles. G is for the first circle, f is for the first circle, g dash and f dash is for the next circle. And similarly, we can use this equation to find the equation of the circle. So now for S, we know this is the format. What is F and what is G? So this is the format 2gx, 2fy plus c. So 2gx, 2g is equal to 4. So from this we can say g is equal to just divided by 2. That is 2. Right? What is F? Also similarly divided by 2. So is equal to minus 3. What is C? The next term, 3. So this is for the previous circle. Now the new circle, S dash. Do we know G and F? Yes, we do. How? Because they have given that this circle, the center coordinates of this circle is 1, 1, 1. Okay. So if it's 1, 1, what is G dash? So 1 is minus G dash. So G dash is minus 1. What is F dash? Also minus 1. What is C dash? We don't know, right? To know a circle, to draw the equation of a circle, we need G, we need F, we need C. We know G, we know C, but sorry, we know G, we know F, but we don't know C. How can we get C? From this equation. Because we have already been told that these two circles intersect each other orthogonally. So let's call it 1. So from 1, we substitute 2 times. What is G? 2. What is G dash? Minus 1. Plus 2 times F. What is F? Minus 3. What is F dash? Minus 1. Is equal to what? C plus C dash. So what is C? 3. What is C dash? That's what we need to find. So by simplifying this equation, we can find C dash. So 2 times 2 is 4 into minus 1. So it's minus 4. 2 times 3. So minus into minus is plus. That goes off. 2 times 3 is 6. So it's plus 6. Is equal to 3 plus C dash. Minus 4 plus 6 is 2. Is equal to 3 plus C dash. What is C dash? Is equal to 2 minus 3. That is minus 1. Okay. So now we know G dash. Now we know F dash. Can we find, and we just found C dash. Can we write the equation of S? S dash? Yes. So S dash is the same as x squared plus y squared plus 2gx plus 2fy plus C is equal to 0. Just substitute. So S dash, I will write it here. So S dash is equal to x squared plus y squared plus what is 2gx? G is minus 2 multiplied by 2 is minus 2 x plus 2fy. What is f? F is also minus 1 multiplied by 2. That would also be minus 2. Y, what is C? We just found it. It's minus 1. Minus 1 is equal to 0. So this is the equation, the circle that intersects the previous circle orthogonally, and it has the center minus 1, minus 1, sorry, 1 and 1. So what did it do? Whenever there's a circle that intersects orthogonally, this is the equation you need to remember. 2g dash plus 2f dash equals c plus c dash. From the center coordinates they have given, we can already find g dash and f dash for the circle. But to find c, using the equation of this and this, we substitute for this equation and we found c dash. So we know g dash, f dash, and c dash. By substituting it to the common formula for the circle, we can find the equation x squared plus y squared minus 2x minus 2y minus 1 is equal to 0. So that is the end of the 9th question. So let's move on to the final question. So the last question is regarding trigonometry. Solve the equation cos x plus cos 2x plus cos 3x is equal to sin x plus sin 2x plus sin 3x. The x is less than to pi by 2 and greater than to 0. Right, let's do that. Cos x plus cos 2x plus cos 3x is equal to sin x plus sin 2x plus sin 3x. Right? And x is less than to pi by 4, pi by 2, and greater than to 0. Right. Now what do? We need to solve it. So when you get to solve a question like this, so it's easier if you have it in terms of multiplication. For example, you have like something like this into something like this is equal to 0. If you get it in this form, you can directly say that this is equal to 0 and or this is equal to 0, and then you can find the value for x. So solve means we need to find the value for x. So how do we get this addition terms in sort of multiplication? So for this, we can use the sine and cos addition formula. So if you remember, sine A plus sine B if you get sine plus sine can witness 2 sine cos. a plus b over 2, a minus b over 2. And then cos plus cos can be written as cos plus cos is 2 cos cos. A plus b over 2, a minus b over 2. So now the addition thing can be represented as a multiplication. So can we use this here? Yes, we can. So, but the thing is, if you directly go and try to apply this, you might fall into trouble. So if you take these two, cos x, cos 2x, and try to put this formula, then you get 2 cos a plus b, x plus 2x is 3x over 2. So cos 3x over 2, and the next term would be a minus b, 2x minus x, x over 2. So you get cos x over 2, cos x over 2, 2x, 3x over 2, and here you have 3x. So you can't really do anything with that, can you? So, but if you think instead of doing these two terms, what if we do these two terms? So before applying, just think of it and then do it. So now if you apply this term, x plus, now if you a plus b over 2 would be x plus 3x is 4x, divided by 2 is 2x, and the other one would be x. Now, see, you can see there's a 2x here. So if we get 2x here and you have 2x here, we can take that common. So instead of doing for the first two, we'll do second, first one and the third one. Okay. Cos plus cos is 2 cos cos. X plus 3x over 2, that is 4x over 2 is cos 2x. And cos 3x a minus b over 2, 3x minus x is 2x, divided by 2 is x. Now, you can say x minus 3x over 2 or 3x minus x over 2 because cos minus theta is also cos theta. So there will be no problem with that. So 3x minus x would be 2x divided by 2 cos x. The remaining term is plus cos 2x. So we'll do the same thing for the next side as well. We'll take these three and do the same form. Sine plus sine is 2 sine cos. X plus 3x is 4x divided by 2 will be x. Sorry, x plus 3x is 4x divided by 2 is 2x. Cos is 3x minus x, that is 2x divided by 2 is x. What is remaining? Sine 2x. Now you can see cos 2x is common here, sine 2x is common here. We'll take the common factors out. Cos 2x, 2 cos x plus 1. In this side, we can say what is common? Sine 2x is common. So let's take that out. Sine 2x be 2 times cos x plus 1. Right? I'll erase this part. Now, immediately as you see this, don't go and get these two. Then what you'll do is you'll cancel one answer. So instead, we'll take it both the same side and we'll take a common. We'll take now these two are common and we'll take the common factor out. So don't cancel this, otherwise you'll lose one answer. So I'll take this to this direction, that is minus, and then I'll take 2 cos x plus 1 outside. 2 cos x plus 1 is common. If you take 2 cos x plus 1 outside, what is remaining? Cos 2x. I've taken this to the next side, which means it's minus, and this has been taken outside. That means what is remaining is minus sine 2x is equal to 0. Okay, now we have this format. This multiplied by this is equal to 0, which means either this is equal to 0 or this is equal to 0. So let's consider both cases. 2x, 2 cos x plus 1 is equal to 0. This is equal to 0. Which means if you substitute cos x, if you simplify, cos x is equal to, you take this side, it will be minus 1 divided by 2 minus half. Now, can this happen? We have already been given that x is less than or equal to 5 by 2 and greater than or equal to 0. So, which means it's in the first quadrant. In the first quadrant, cos x never becomes minus, it's always positive. So we can't take this equation. Okay. this is not valid. So we need to take the other side. Cos 2x minus sin 2x is equal to 0. So I'll take both the next side. So we can say sin 2x is equal to cos 2x. You can divide both sides by cos 2x. If you divide this by cos 2x, it will become 1. If you divide this by cos 2x, it will become tan 2x. So tan 2x is equal to 1. How I got that was I divided both sides by cos 2x. Okay. Sorry if it's small. So tan 2x equals 1. So which value of tan gives you 1? It's 5 by 4. But can you just say it's 5 by 4 or 45 degrees? Because it could be in any quadrant. But we already been given that it's between 5 by 2 and 0. So we can directly say 2x is equal to 5 by 4. It's 45. If 2x is equal to 5 by 4, what is x? X is equal to 5 by 8. This is the answer we need. Okay. So what did we do? We have this addition whole thing formula. What we needed was to solve it, find the value of x. So first we use the cos and the sine addition formulas. So instead of doing the first one, we did the first and the third. So we can take the common factor out. So 2 cos x, and we took the cos 2x out. Same thing we did with the next time. Sin 3x plus sin x. We did it. And then we took the common factor, sin 2x out. I mean, don't cancel this two. We took the whole thing to the next side and then we simplified. So this into this is equal to 0. That means either this is equal to 0 or this is equal to 0. If you put this is equal to 0, you get cos x equals minus half. But cos x cannot be equal to minus half because it's in the first quadrant. So this answer we cannot take. So the next answer is cos 2x minus sin 2x is equal to 0. So by simplifying this, we'll get tan 2x is equal to 1. And we know that tan becomes 1 only when that is 5 by 4. So that means x is equal to 5 by 8. That is the end of the first part of the 2016 paper. So I hope you understood. Okay. So thank you very much for everyone participating in. It's been a long time actually since I actually taught maths. So sorry if there was any mistakes and stuff. So hope you understood it. So if all the people who are doing the exams this year, like all the best, do your best. Just like it might be a lot of stress. People might be asking like exams are close and everything, but like just do your best. Don't take notes. So and as I said, practice the past papers doing it alone. Like, just because I did this past paper in this seminar, this past paper in this class, so I've done a lot of past papers, so I'm going to be the island first. Or don't even think like that. Just try to do the past papers alone, and that will really help you. So thank you very much once again for like coming and listening and staying all the way up till the end. So that's it from me, and over to you. Good night.